Hi, this is a quick biomedical visualization tutorial, and the subject here are fluorophores. Fluorophores, chemical compound that can be used to mark certain structures in types of microscopy that, this compound, when excited, can emit light, allowing different structures to be seen. In some cases, when the fluorophore leaves that excited state, it will release a photon. And this tutorial is all about how to simulate that. So what you see here is a simulated bed of photons, a bed of fluorophores in their excited state, glowing green. And what we want to have happen is occasionally, randomly, each of these or one of these will go down to a state out of excitation, so it will turn sort of gray and will release a photon. So what we want to do in Maya is use particles, and the technique we'll be using are particle collisions to trigger these events. And the event will be change in color of individual fluorophores, and then from that position releasing another particle which will be simulating the photon. So I can just play the animation here and you can see what I mean. So you can see that every so often one of these particles in the bed of fluorophores turns gray and releases a white particle, a photon that rises up. Okay, this is a pretty simple setup, and there are probably many ways to do this, but what I'm doing here is using collision events to trigger both of these occurrences. So let me build this from scratch and then we'll see. Save this file and create a new one. So the first thing we have to do is create a field of, I'm using nParticles, so we will select the nParticle tool and make sure create particle grid is turned on. And then I'll just use my grid snapping to put one in the corner here and one in the corner here and hit enter. Then we've got a field of particles. Now by default these are cloud particles and they're not going to react to gravity, which is what we want. We don't want these to fall down. So let me just name these appropriately. These are the fluorophores. And right now if I play the animation, let me give myself some more frames to work with here. So 1,000 frames. If I play the animation they should turn blue. Because right now they're set such that if we look in their shading attributes here, oops, closed it. Over time they go from white to blue. We want them just to be a consistent color. We want them to start this kind of bright fluorescent green. Now right now the color of these is hooked up to this ramp. This is an RGB PP value, RGB per particle value, and you can see that's down here in the per particle attributes. It's hooked up to this internal color ramp. We're going to break this connection in a little while so we can control this with an expression rather than with the ramp, but we'll get to that in a minute. So the first thing we have to do is somehow select individual particles here and have a random event happen to turn gray, and then the second event is to release a second particle that will rise up. Now there are probably ways to script this just to select at random any one of these based on their particle ID, and you could write a script for that pretty easily. But I'm going to do it in a slightly different way. I'm going to create a collision event. So I will first create a polygon plane and just scale this up so it's about the same size as our field of particles and just move it up a little bit. I'm working with a black background just so it's easier to see these particles. And I'm going to use this plane as a particle emitter. I'm just going to delete its history and freeze its transformations and go to nParticles, create particles, emit from object, and make sure it's turned to surface. Doesn't need any speed because we're going to let gravity just pull them down. It has a normal speed of 1. Doesn't really matter. We'll just create this. Now if we play the animation, you can see the particles are appearing on the surface, but the default, if you're not familiar with this, when you go to nParticles, create nParticles, the default is the cloud particle. And if we look in the shape node of this new particle, we'll see under the dynamic attributes, pardon me, the dynamic properties, ignore solver gravity is turned on. So I'm just going to turn that off. So they will react to gravity, and I'm going to change their color too, just for now. Ultimately, we're going to hide these, but I'll just make them red so they're easy to see. Now if we play back the animation, so you can see they are striking those, so there is a collision happening, but they're knocking them out of the way. So let's solve that first problem. I don't want these green particles, these fluorophores, to move. Let me name these red particles before I move on. So these are, I'll call these colliders, or just collider. So these green ones, one way we could have them not move is turn off collisions in the fluorophore shape. If we go up to the top here, collisions, and collide is turned on. I could turn that off, and when the other ones fell, they would just go through them and there would be no collision, but that would negate the rest of this technique because I need that collision event. So if I want these just to stay still, I can do something else. In dynamic properties, under here beside drag, I can just turn this value up to something very high, and that means they'll just stay in place. It would need a lot of force to move them, and these particles simply don't have enough force to do that. So you can see they're being struck by those red particles, and some of them are finding their way through then. But the green ones aren't really being disturbed. Looks like this one may have moved over slightly. I'm not sure. Oh yeah, it did. Okay. Oh yeah, that's funny. I'm going to turn this up even higher to see if that will help. Just let these fall again. They are pushing them out of the way slightly. I can see they're changing their position. So we could try things by turning the damp all the way up to a high value. See if that helps. No, it's still pushing them out of the way slightly, but it's pretty minor. So we'll carry on from here and go to the next stage. So what we want to have happen is the particle to come down, hit one of these at random, and then have it change color. So let's deal with the color change first. So right now, if I go down to RGB PP, it's being controlled by that ramp. I can right click on it and go to break connection. And then I can write an expression for this. So in the creation expression, I can say RGB PP is equal to, and this is a vector variable, so I want it to be 0, 1, comma 0, so that's RGB, so 0 red, 1 green, 0 blue. End it with a semicolon, create. Now, before I write an expression for it to change color, I have to create a collision event. So with the fluorophore selected, the bed of particles here, I'm going to go to nParticles and open the particle collision event editor. And with fluorophores selected on all collisions, I don't want anything to emit, and I don't want the original particle to die, although you could do it this way too. We're going to create an event. So it's an event that causes nothing to happen, but it will be registered. Now, hopefully this will work. If we go in here and say if bracket event is equivalent to 1. So if the event happens, essentially, then RGB PP equals, let's say 0.5 comma 0.5 comma 0.5, so it'll be gray, mid-gray. Okay. So now let's see what happens. So our particles will start to descend from above. Yeah, and then you can see they strike these particles and now they turn gray. You can see that the red particles are striking more than one, and we'll fix that. And sometimes they stay on the surface amidst these particles and roll around a little bit and strike a bunch of them. So we're going to have to change that a little bit. The first way we're going to do that is create another collision event, but this time for the collider particles, the red ones. So with the collision event editor open, select the other particles, the colliders, and then we're going to create a new event, but before we do that, we're going to say original particle dies. And click on that and create event. So now we can go back and play the animation. And so the red one should descend, strike the green one, cause some of them to turn gray, and then the red one should just die immediately. Okay, so that's good. So we're almost there. Now we want another particle to be emitted when these ones turn gray and float upwards. So we're going to do that in the particle collision event editor as well. Again, with the collider particle selected and event 0, the one that we just created, selected, we're going to turn on emit. So when you make changes here, you don't have to activate them. They'll just be acted on when the event happens. So we're going to emit a new particle. Actually, one thing I forgot. We want to create a new particle first for it to emit. So I'm just going to go into nParticles, create nParticles, and just create a simple omni emitter. The values don't matter at all. It's going to be called new particles. Create. Now if I go into my outliner here, so I've got the new particle that was created, nParticle 1. I'm going to call this Photon. And then the emitter that's creating them, I'm just going to delete. I don't need that. Okay, so now I've got a new particle called Photon. Back to the particle collision event editor, collider event 0. We're going to emit, and the target particle we wanted to emit is Photon, the one we just created. Sometimes you get a warning here when you do this. If that's the case, click on Update Object List first, so it includes Photon. I didn't get the warning, so I'm going to do that again. I'm not sure that it worked. Okay. Now we want this particle to rise up. Again, it's going to be a cloud particle. Let's select it and change its color so we can see it. We want the photon to be white. So here we can just delete that. So it's constantly, is that white? That is white. Okay. And with that one selected, we'll add a field. I'll just use a uniform field and set it to +1 in the Y value and give it a magnitude of 20 or something. Create that. And then I'm also going to add a turbulence field just to make them move around a little bit. Fields, turbulence. I don't want a volume shape. I don't want any attenuation. And I'll give it a slightly higher magnitude. I'll call this photon mixer. All right. Now let's see what happens. So the red ones will descend. I should turn up their speed so we don't have to wait quite so long. But anyway, here they go. So something's not working, obviously. They're striking and turning gray, but the photon particle is not being emitted. So let's just cancel this animation and figure out what's going on. So, collider, that event didn't seem to take, so turn that on. Number of particles 1. Oh, maybe I didn't do that. Photon. Just click another field. I'm going to turn off inherent velocity. Okay. Now let's hope for the best. Rewind this and play again. I've done this a few times now, and it's a little finicky in terms of the order in which you do things. There we go. It is creating the white particles now. You can see them just floating up from the surface. And the turbulence is maybe a little too strong. It's pushing them around a little bit too much, but all that stuff can be tweaked. Okay, so that's working. I'm happy about that. So let's solve a couple of problems. If I select this red particle here, it looks like none of them are making it through the green field, but they're also touching too many particles in some cases. So we want to maybe change the quality of their collision parameters. So right now they are of a certain size, 0.2 units, so particle size radius here, and then their collision width scale is 1, so their collision border is the same size as they are. I can make this smaller without changing the size of the particle, if I like that size, by reducing the width scale, say to 0.5. And so now it's just the core of the particle, half their diameter or their radius, or both, I suppose, will be the measurement by which the collision is evaluated. So now let's see how this works. This is chugging along a little bit. It's a little better. Still getting multiples struck here. What we want is more like this one here, where just a single fluorophore is struck. So we can actually select the fluorophores themselves and reduce their collide width scale to something quite low. Now I may have to turn up the number of red particles that descend so we can see, because more of them are going to sneak through, like this one. So let's just play this again. See them descend. That's better. So you can see some of them are escaping through, so we're not getting quite as many hits, but we're getting the single hits that we want. Okay, now there still are some double hits here, and these white ones too are colliding. So we don't want these ones to collide because they can then hit the fluorophores and turn them off. So turn off collisions for the photons. And some of these red ones are escaping through. So I'm going to write another expression to kill them if they fall below the level of the fluorophores. So if I go down to the per particle expressions under position here, I'm going to write a runtime expression. Before or after dynamics shouldn't really matter. And we're going to declare a new variable called vector, or it's a vector type variable, and we'll call it $POS, and that equals position. So it's just a variable that will collect the position of every particle and put it into that container, that variable $POS. And then we can use that to assess where they are in the world. First thing I'm going to do is change the type of lifespan this particle has. So right up here under lifespan, right now they're on live forever. I want to change this to lifespan PP. so lifespan per particle, so I can change how long each particle lives based on certain conditions. So I will say if $POS dot y, because this is a vector, there are x, y, and z attributes here, and we want to take advantage of the y value from position, so the up and down value in our world. So if their position in y is less than 0, so falls below the 0 value in y in the world units, lifespan PP equals 0, semicolon, and with a curly bracket. Right. So let's play this through again, and I'm going to turn up the amount of particles that fall through. Now, I should say that ultimately I'm going to turn off the visibility of these particles, but in order for the simulation to run more smoothly, the ones that we don't need anymore, because the ones that strike the green things are going to die, and that will lighten the load. But the ones that fall through will just go on forever. And so I just want them to die if they fall through our grid here. So let's just go to our outliner and find our new particle emitter. I'm going to turn up the rate to 25. And then I should probably save this in case something terrible happens. Trial number 4. Okay. So now a lot more red particles should be born, and they are, and they're falling down. There we go. And then we're getting the effect we want. And you can see none of them are going below the 0 value. You can see some of them are trying to escape down here, but they die when that happens. The white ones are kind of going all over the place. I probably want to change that turbulence. But this is the effect that we're going for here. So the final thing that I would do is, hide this plane. Of course, we don't want to see this, so it just turns visibility off. We could turn off the visibility of the particles, but sometimes that just negates their effect. So an easier way to do this is to just turn their opacity down to 0. So the opacity scale here, just grab this, turn it down so we don't see the red ones anymore. If we deselect, and I'm just going to turn down that turbulence so it's not so crazy. Just a lower value. And then let's see this at work. So we're not seeing the red ones anymore because their opacity is turned off, but we should see their effect. Oh, we are seeing some of the red ones. That's funny, they're flashing up there. They're just flashing when they're born. I might have to turn off their opacity in a different way. But anyway, the effect is working. Occasionally just those, seemingly randomly, those fluorophores turn from green to gray and release a photon. So quite apart from this subject of fluorophores and photons, the use of collisions with particles can be broadly applied in lots of situations. So just remember that when you're doing this with the particle collision event editor, you can make a collision happen like we have here. I've declared a collision event for the fluorophores, but I haven't caused anything to happen when it happens. So all that happens is that that event is registered by Maya. Then, if we go back to the fluorophore and look in the expression that we wrote here, so we're just saying if fluorophore shape dot event, so it's now an attribute of this shape node, $, or not $, equal equal, which means is equivalent to 1. So that means if that event happens, then you can make something else happen. Now the funny thing about this that you may notice, and let me just, if I can, zoom in here. Normally when you write an if-else statement, you write if something in brackets happens, and then you normally put a curly bracket and then declare the outcome if that if event is satisfied, which we've done here. But I've noticed when you're calling on an event, if you put the curly brackets in, it doesn't work. And this is no advanced technique or anything. If we just hop over to my web browser, let's see, I was looking at fluorophores here, but if we go into the Maya user guide, this is where I got this little expression from in their area about working with collisions. There's a lot of value here in the Maya help files. This is from my Autodesk 2014. I'm using 2015 now, but people sometimes forget how much good stuff there is in the help files. It's sometimes hard to find exactly what you want, but you can see this is written here, and I just grabbed the first line. And you can see they've written the if statement differently. They have if else, but they don't have any of the curly brackets. I don't know why that is, but that's just how it works. So I hope you find some use for this technique, using particle collisions to make interesting things happen in Maya. Okay, thanks.